Okay, so 2.1, we're talking about the derivative and the tangent line problem. So let's look at some definition. Review. Secant line. Secant line is a straight line drawn through 2 points on the curve, and it's going to cross the curve. Tangent line is a line that is drawn with only 1 point on the curve, and it only touches the curve. So that's the difference. Secant line, tangent line. So you have to know the difference between those two. Those are going to help you with a lot of things later on. Okay, secant line, tangent line. All right, so I am going to show you two pictures. Actually, let's do one at a time. This picture. So you're going to take out the whiteboard that's underneath your desk with some markers. You're going to draw a secant line through this point P, and you're going to show that to me. Secant line through this point P. Okay, so secant line is basically a point or a line that goes through 2 points. So it could be 2 points like this. So one of the point has to be P, the other point is just somewhere else. Doesn't really matter where. Okay, let's try another one with a parabola. Draw a secant line. Okay, good, 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 good. Okay, these are all good. All right, you guys are perfect. Very good. So secant line just means a line through 2 points. So it could be anywhere on here. One of them just has to be P. Now let me ask you another question. If we know the coordinate of these 2 points, so for example, here we have 2 points. If I know the coordinates through those 2 points, can I create an equation of a line? Yes. Yes. If you want to create an equation of a line, you just need 2 points, find the slope, and you can find the equation. All right, next. Now, I want you to draw tangent line. So this same one, I want you to draw a tangent line. Okay, that's good. Okay, good, 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 good. Okay, you guys are all good. Okay, very good. Good, 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 good. Okay, Judith, you're good. All right, Peter, you're good. Okay, Jaden, good. Jim, good. All right, George is good. Okay, so this is going to be like this, right? Tangent line only goes through that point, does not go through another point. Now let's look at this one, tangent line. All right, you guys are good, 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 good. Good, good. All right, so tangent line is going to be like this, only through 1 point. Now let me ask you another question. Can you write an equation of this line? No. No, you cannot. You need 2 points to write an equation. This one only has 1 point. So now is the problem. In everything you learned up to this point, you can write a line because you just need to find 2 points. This is the time where you only have 1 point and you still have to write a line. Therefore, we need calculus. So this is the whole idea of derivative, which is what we're going to learn from now on, is how a secant line becomes tangent line. So this is the story of how a secant line becomes tangent line. And I'm going to show you how that happens. So let's put your whiteboard and markers away. Now, you may recall from last year, or you may not have remembered from last year, but basically derivative means slope. You got to remember that. That's the big idea. Derivative means slope. Derivative means slope. So let's talk about slope. What is the equation, or what is the formula to find slope? Oh, no. y2 minus y1 over x2 minus x1. Okay, that is slope, right? And you need 2 points, point 1, point 2. Now, since we're in calculus, we're not really going to write y that much. We're going to write it in terms of f of x. So x2 minus x1. What's another way of saying y2? F of what? X2 minus f of x1. Okay, so now let's say that you have 2 points. So You have 2 points here. And this is x1, this is x2, and they both have some y value. So this is f of x1, and this here is f of x2. And you're trying to figure out the slope of that line that connects these 2 points. Okay, so now the question is there another way to write this whole thing? Yes, there is. Now we're going to try to combine x1 and x2 into just x1 in terms of the distance between them. So from x1 to x2, let's say this is a distance of h. So then what's another way of saying x2? Yes, x1 plus h. So all the x2s, I can change it to saying it's just going to be starting from x1 and then move over h. Therefore, my slope becomes f of x1 plus h minus f of x1 over x2 minus x1. Okay, so we're still talking about slope, right? We're just talking about the slope between 2 points, point 1, point 2, and we're trying to figure out what the steepness of this line is using the slope equation. And I have gone from our normal formula all the way to x1, x2. Now it's just only using x1. Let's think about this a little bit. Yes?
For the bottom, would you put x1 plus h in parentheses for the denominator?
Yes, that's what I need. I'm actually going to get to that point. So x2, remember, becomes x1 plus h. So in the denominator, it is actually a x1 plus h minus x1 because that part is just x2. And you can see that in the denominator that x1 is going to cancel, right? So then this becomes f of x1 plus h minus f of x1.
So it's h.
Yeah, so it just be h on the bottom.
Okay, so this now is our very simplified secant slope formula in terms of just x1 and the distance between x1 and to the next point, whatever that point is. Okay, now this is a secant line, and we're talking about derivative, which is the story of how a secant line becomes a tangent line. So this is, I'm going to show you if after you've copied this down. Okay, so basically, let's say that we have 2 points. We have 2 points, and so instead of 2 points, let's say that I have 1 point P, like before. And I want to figure out the tangent line slope, which is this one. And like 5 minutes before, we said that's impossible, right? We said you need 2 points to figure out that slope. So what we're going to do is we're going to be very smart, and we're going to say, I cannot figure out the slope of that tangent line. How about I start with a secant line? So I am going to draw a secant line instead through 2 points. And what I'm going to do is I'm going to bring that point that is not P, I'm going to bring it closer to P, and closer to P, and closer to P until it's almost next to P, to the point where that distance is so small, it's almost at P. And we can say that looks just like if it were on P, therefore creating a tangent line.
Almost like a limit.
Yes, that is why, yes, that is the limit. So basically, we're taking 2 points that's secant, creating a straight line, and bringing it closer and closer and closer and closer until it's almost at this point. Of course, we cannot be at the point, or else it will be nope. Right, it's actually just 1 point, you cannot solve it. But once you get really close, you can kind of approximate it. So secant line to tangent line. Okay? So this is the whole idea. Secant line is what we call the average rate of change. Secant line is the average rate of change. And then we're going to do an acronym. So AROC. So we're going to call it AROC. Average rate of change. Average rate of change is the secant line slope. Average rate of change is the slope of the secant line. Slope of the secant line. All right? Please keep it in mind. AROC is the slope of the secant line. Next, instantaneous rate of change. Instantaneous rate of change. IROC. IROC. So, instantaneous rate of change is the slope of the tangent line. Is the slope of the tangent line. Okay? AROC is the slope of the secant line. IROC is the slope of the tangent line. So that's the difference. We kind of proved a formula from a slope to just a function where you only have x1 and in terms of how far you are to the next point. And we said it is the story of how a secant line becomes a tangent line. Therefore, remember the slope is f of x1 plus h minus f of x1 over h. And what's happening is that we're bringing this distance really close to the original point. That is when h goes to 0. The distance goes to 0, as if there is no gap. Therefore, instantaneous rate of change is limit as h goes to 0. So it's the same formula because we're just looking at slope. One of them requires 2 points. The other one only requires 1 point where h goes to 0, where the gap goes to 0. Okay? So many confused looks. Yes?
If you have a point for, just like the 1 point for the tangent line, can you just plug in 0 point or a super close number for h?
Yes, you can. But in the whole idea of it is that you're still not close enough. So that's why we need limits, saying that you're basically going to 0 and just not at 0. Okay, so what you're going to do is I am going to show you a question. You don't need to copy any of this down, but you need to decide, is this IROC or is this AROC? Is this asking for the instantaneous rate of change or is it asking for the average rate of change? First one, a particle moves on the line away from its initial position so that after t seconds, it is s equals 2t squared minus t feet away from its initial position. What is the average velocity traveled between 1 to 3 seconds? AROC or IROC?
AROC.
How'd you know?
Average.
Very good. Look for the keywords. Look for the keywords. Okay, next one. A bacterial cell is spherical in shape. Find the rate of change of the volume of the cell with respect to the radius when the radius is 2. IROC. Why IROC? At that time when it's 2. Okay, there's no average at 2, so we want IROC. So this is AROC. This is IROC. Okay, next one. The number of dollars in the total cost of manufacturing X watches in a certain plant is given by this function. Find the cost per watch when the number of watches is 40.
IROC.
Good, you guys are getting really good. So IROC because we want to figure out the change at 40. Okay, last one. What is this? AROC or IROC? AROC. Why is it AROC? Secant line. Good. All right. Let's write this down so we can compare. AROC is f of, instead of x1, we're just going to call it x because since there is only one x, there's no need to say 1 or 2. So f of x plus h minus f of x over h, that's AROC. IROC is that same formula, but we are making h go to 0. So it's the limit as h goes to 0. So that is the difference between the two. Okay, so now we're going to solve some problems. Okay, let's look at the first problem. Find the slope of the tangent line to the graph f of x equals x squared plus 1 at the points 0, 1, and negative 1, 2. What is it asking for? AROC or IROC? That's the first thing you got to ask yourself. AROC or IROC? Okay, talk to your partner. Read the question. We want slope for sure. We want slope. What kind of slope? Tangent line. IROC.
Yeah.
We want IROC. Okay, even though they give you 2 points, please don't get tricked. Make sure you read the question. We do want tangent slope. So, take out that formula. IROC formula. Limit as h goes to 0 of f of h, x plus h minus f of x over h. All right, so this is where we need to plug things in. Well, we need it at 2 points, 0, 1, and negative 1, 2. We're just going to do 0, 1 first. Okay, first we want f of x plus h. F of x plus h. Well, what is f of x? X squared plus 1. Sorry, x squared plus 1. Okay, so what we're going to do is plug that in. Okay, so f of x plus 1 means anywhere you have an x, you're going to put, sorry, I said that wrong. F of x plus h means anywhere you have an x, you put x plus h. So anywhere you have an x, you put x plus h plus 1. So I take that function, wherever I have an x, I put x plus h.
Oh.
In this function, wherever I have an x, I put x plus h. That's what f of something means.
Yeah.
Okay? Minus f of x. F of x is x squared plus 1. And then divide everything by h. All right, now we need to remember what happens in limit. If I put in 0 right now as h, what's going to happen?
Undefined.
Not really undefined.
Does not exist.
0 over 0. What does 0 over 0 tell us?
Gotta keep going.
There's a limit. There's a limit. You got to try something else. So what we're going to do is FOIL this, and then things should cancel out. Okay, x squared plus 2xh plus h squared plus 1 minus x squared minus 1. Just x plus h squared, you got to do that in your head so it's quick. And then the other part, just distribute a negative sign. That's going to cancel. That's going to cancel. So we have a limit as h goes to 0 of 2xh plus h squared over h.
Can you?
Hold on. Let me finish this problem. Okay, so the next thing that's going to happen is that h definitely has to cancel. If it doesn't cancel, then you shouldn't have gotten a 0 over 0 in the first place. So this is 2x plus h. Now that's when h goes to 0, so that is just 2x. So what is 2x? Yes, this is the slope at of this tangent line, right? At just x squared plus 1. We haven't plugged in 0, 1 yet. So this is basically the derivative. This is the derivative. So the way you write derivative is you put f of x with a prime. That prime means this is the derivative. So the derivative is 2x. The derivative is 2x. Now the question is, what is the tangent slope at 0, 1? That means what is this going on at 0, 1? Well, this slope does not depend on y. It only depends on x. So we just put in 0 there. So that is 2 times 0, which is 0. So that means the slope at that point is a flat line of 0. Yes?
Quick question. Sorry, I didn't follow you. Like, what's the f derivative?
Oh, so f prime. So if you recall from geometry, this is called a prime. Prime just means derivative. So I'm saying the derivative at x of x is 2x. Okay, so
Why do we like discard the h?
it's the limit when h goes to 0.
Oh,
Okay, so now the question is, what is the slope of the tangent line? 0. Okay? Now the next question will be easier. The question is, what is the slope of the tangent line at 1, 2? Well, we already know that the slope formula is 2x. We just have to put in 1. So the slope at 1 is 2. Okay, let me recap. first thing is you basically find the slope formula using the IROC formula. That's going to give me the slope equation or the derivative for every single point. Next, you plug in just the x value because the slope only depends on the x value. And then that's it. You're trying to find the slope at that point.
It was -1, 2.
Yeah.
Wait, why is it negative?
Oh, yeah.
Because it's
It says
negative.
-1.
Oh, I'm sorry. I didn't see that. Negative, yes. -2. All right, let's try another one. Find f prime x. What is f prime of x?
The derivative.
Derivative. Derivative, is it IROC or AROC? IROC. Derivative is always IROC for this function. Okay, so let's do that first. IROC, take out the IROC formula. Sorry, not x. H. H goes to 0. F of x plus h minus f of x over h. F of x plus h. What do I do? Plug x plus h into the function. The function is square root x. At this time, if I plug in h equals 0, what's going to happen? 0 over 0. What does that mean?
You keep going.
You keep going. Use some trick. Now, this is basically exactly what we did last chapter. What do we do? Conjugate. Very good. So we need to multiply by conjugates. Okay, so you need to remember how to simplify all that. So go ahead and do that. Did anyone get the derivative? Yes, that's correct. So now the question is, what is the slope at 1, 1? We only care about 1, so plug it in. 1/2. What is the slope at 4? 1/4. What is the slope at 0? Undefined. So then that means when you actually look at this equation or the graph of square root x, there is no slope at 0. And we'll talk about why there is no slope at 0. That point is very special there. All right, we don't have time to finish the other stuff, so let's practice just the derivative. And if you can, find a tangent line. If you cannot find a tangent line, we'll do that tomorrow.